about functions. Functions. A function is a relationship between two quantities. The domain represents the x's, and the range represents the y's. The domain called the input and the range called the output make up a set. Each domain is paired up with exactly one range. A function is only present when the domains, also known as the x's, aren't repeated. A function can be represented in three ways: order pairs and table of values, graphs, and function rule. This will all make sense through some examples and explanations.
Let's get started. Is this a function? Now, when we look at this chart, we should be able to tell whether it's a function or not. In order for it to be a function, x can't be repeated. In the left column here, we notice that none of the numbers are repeated. Therefore, our answer is yes, it is a function. Another type of chart you may see is a mapping diagram. In this, all the x values are listed numerically over here on the left side. And in another column on the right side, the y values are listed numerically. For example, we take the bottom coordinates and list out all the x's and the same with the y's from least to greatest. Now you simply take the x values and connect it with the y value from an arrow. So we take the 2 to the 3, the 7 to the 9, the 4 to the 9, the 3 to the 8, 1 to the 4, and 6 to the 1. Now we answer, is this a function? Well, let's do this together. There are two values of y that are repeated, which are the 9, but no x values are repeated, so yes, it is a function.
Now these are just two independent problems, guys. Simply answer, is this a function? Why or why not? Good luck!
Let's look at the first one, the function table. Your answer should have been no, because the x value 7 is repeated. For the second one, the mapping diagram, you should have gotten yes, because no x values are repeated.
Go.
Even though the 6 is repeated, it doesn't mean it's not a function, because you're only seeing if an x value is repeated, and 6 is a y value.
Function rule is just a fancy way of saying the rule. When you were little, you were used to seeing this, where you would take the input, either add, multiply, divide, or subtract by the rule, and then you would end up getting the output. It was basically just like a chain. Now that you're getting older, you're going to have to start getting used to seeing x and y tables. And you will also see graphs relating to function rule. Not only will you use a function rule, which would technically be your slope, you're going to start putting it into an equation, which is y equals mx plus b, where m would equal your function rule and b would equal your y-intercept. Now, let's say you're given this table. Our x is our domain, and our y is our range. So, our x's consist of 0, 1, 2, 3, and 4, and our y's consist of 2, 4, 6, 8, and 10. The direction is usually asked to find the equation. Our equation is always or most likely going to be y equals mx plus b. Let's start by finding the rate of change in x. So, to get from 0 to 1, you add 1. To get from 1 to 2, you add 1. To get from 2 to 3, you add 1. And to get from 3 to 4, you add 1. Now, to get from 2 to 4, you add 2. To get from 4 to 6, you add 2. To get from 6 to 8, you add 2. And to get from 8 to 10, you add 2. Now, in this case, you were given the y-intercept, but this is not always going to happen. Since you were given 0, 2, you know that the y-intercept equals 2. So let's try finding our slope. Let's start by picking 2 points. Now, let's pick the first 2 points, which are 0, 2, and 1, 4. Now, to find slope, we use the formula delta y over delta x. Delta is basically finding the difference. So, if we're going to go one way, we can only go one way. So if we do 4 minus 2, we have to do 1 minus 0. So 4 minus 2 over 1 minus 0, which equals 2 over 1, which gives a slope of 2. Now, we have to use the equation y equals mx plus b. Over here, we're told that the y-intercept is 2, and over here, we're told that the slope is 2. So, we get y equals 2x plus 2, and that is our answer. Now, let's see if it works. So, let's go back and pick a point, another point. Let's pick 2, 6. So, we get y equals 2x plus 2, which was our answer. And we picked the point 2, 6. So we get 6 equals 2 times 2 plus 2. So we get 6 equals 4 plus 2. Now 6 does equal 6, so yes, this does work. Now, finding the slope like this sometimes can get really long. So when we're finding slope, we're using delta y over delta x. Finding the rate of change here is basically delta y, and finding the rate here is basically delta x. So we can simply do 2 divided by 1 to get our slope of 2. So when finding slope, we can just simply divide the rate of change of y divided by the rate of change of x to get slope. And then you put the slope with the y-intercept to get the equation y equals mx plus b.
Sometimes you're not going to be given the y-intercept. Over here, you are given that 0, 2 is your intercept. But because we already know our slope, we can use that to figure out the intercept on our own. Let's pretend that we didn't have the intercept too. So let's put b over here. But we already knew what our slope was over here by finding delta y over delta x. What we can do is take one of the coordinates from back over here. So let's take 3, 8. You simply plug in those numbers in this equation. Y, which is 8, is equal to 2x, x, which is 3, plus b. 8 is equal to 6 plus b. Minus 6 on each side. And you get that 2 is equal to b, meaning 2 equals your y-intercept.
Now it's time for independent practice.
If you need more time, please press pause now.
So, you should have gotten y equals x plus 13, which is the correct answer. But even if you got y equals 1x plus 13, that is the same thing. Because whenever you multiply a number by 1, as you know, it's the same number all over again. So this is the right answer. Okay, so let's start with this example. Functions can be represented by graphs too. You choose a point that's shown on the graph and you use that to write the function rule, just like we learned earlier. But this time, we don't use a table. Okay? So, there are 2 types of functions, linear and nonlinear. This graph shows a linear function because it goes on forever and ever. So, let's find out why this is a linear function. In order to find slope, you use the method rise over run. So let's plug that in here. Rise, run, rise, run, and so on and so forth. And you realize that the rise is 2 and the run is 1. And that's how it goes on forever and ever. So let's plug that in. Rise is 2 over run, which is 1. You simplify that to find 2. This is your slope. And this is a special thing about linear functions. The slope is always consistent. And for this example, it's pretty easy to find the linear function and the function rule, which is y equals mx plus b. And now you plug it in. Since you know that 2 is the slope, you do y equals 2x plus b. And we've shown here that 0, 2 is the point that it starts at. So that means that 2 is the y-intercept. Simplify and plug in the numbers to get y equals 2x plus 2, which is your function rule. It's pretty easy, and it's important to remember that there are 2 types of functions. Not all functions are linear like this example shown.
Okay, now let's try another example. This graph shows a non-linear function. We notice that these points are all scattered, as in they have no way of increasing or decreasing. They're all over the place, but that doesn't mean that this graph isn't a function. No values of x are repeated, and you can check this through the vertical line test, which I'm going to show you right now. So here you can see that there are no other values for it. 1, 2, 3, 4, 5, 6, 7, and for the rest of the graph. So, as you can see, none of the points on the lines are repeated more than once. So, this is what makes it a function. So, in this case, let's skip right to the vertical line test, starting from 0. None of them are repeated. Same thing with 1, 2, 3, 4. But once we get to 5, we notice that there are 2 of them repeated. Therefore, making this not a function, because there are 2 points repeated. So, not a function.